everyone, welcome back to our channel. Today in this video we are going to talk about one of the major and important parts of the maths and which we come across in many questions, and that is a theorem today, and that is nothing but midpoint theorem. So today we are going to talk about midpoint theorem and also its converse. Also today we are going to prove this midpoint theorem. So let's begin with this amazing initiative. So firstly, we should know what is midpoint theorem. So let us understand and dive deeper into this thought. So firstly, if we understand this midpoint theorem, this is a theorem which says that if we take any triangle, let me take this triangle and let me name this. This side is A, B and C. This is a triangle ABC. Now in this triangle, this is a midpoint of side AB. Let me name it E. Okay. Then if we draw a line which is joining the midpoint of side AC, let me name it F. This side, this EF will be parallel to BC and definitely EF will be half of BC. This is this midpoint theorem. It says that if we take a triangle, let's say ABC here, and if we join any two sides by their midpoints, then the line joining these midpoints will be definitely parallel to the third side and half of it. So that is just if we join the point E, which is the midpoint of AB, and to point F, which is the midpoint of AC, this line EF will be parallel to BC and half of BC. This is this midpoint theorem. Now how we can say this statement? Is it true? Let us prove this with amazing proof. And also we have its converse. This is midpoint theorem. If we talk about it converse, we will talk about it in later. Okay. So firstly, let us prove this statement. If we talk about the proof of midpoint theorem, it is basically, first let us write given statement. Okay. We have been given something. So we have a triangle. Let me draw here. Triangle ABC. Okay. This is that triangle ABC, and in given statement we will write triangle ABC, in which E is the midpoint of AB, E is the midpoint of AB, and F is the midpoint of AC. This, and we join this side. Got it? This is the given, and we write AE equals to BE. Or you can also write E is the midpoint of AB and F is the midpoint of AC in the given statement. Okay, I am writing directly that AF is equals to CF. Got it? This is the given statement. Then we write to be proof. To be proof, we know the statement. To be proof. To be proof, we have now that EF is parallel to BC and EF is also half of BC. We have to prove this statement, right? Then after, let us prove this thing. See, every single proof will be done by this single diagram. Just imagine, you have been given a triangle and that triangle is ABC. And we have two midpoints of AB. We have E. For AC, yes, we have F, and we join these sides. And if we join this, we got our side EF, which is parallel to BC. We have to prove this, right? So how do we prove this? Think about it. Before proof, we have to construct something. Without construction, we can't prove the statement, right? So what we will do, we will construct something. So what I will be constructing is that I am drawing a straight line passing through C, which is parallel to AB, right? A line through C which is parallel to AB till point P. Got it? That side. That is my construction part. You will write in exam that construction part is that a line drawn from C to P which is parallel to AB. Got it? Then after what we will do? After we construct it, then we will join point F to this side and this will cut at point S. You can name anything, right? This point is S. Now the next step you have to do, you have to make these two triangles congruent. And we have studied congruency very well. And we know we can congruent two triangles as where we want, because whenever two triangles became congruent, they are definitely similar, although their area is also equal. So first, let me change the chalk because it's very small, okay? Then after, we need to make this triangles congruent. How we will do? See, F is the midpoint of AC. We have been given. F is the midpoint of AC means AF equals to CF, right? Now, see, angle AFE equals to angle SFC, because they are vertically opposite angle, and we definitely know whenever two straight lines intersect each other, then they follow some properties, and one of them is vertically opposite angles are equal. So these two are vertically opposite angles, so they are equal. Then after, we have that EF equals to FC, FS by construction, right? Then after, these two triangles became congruent by SAS congruency criteria. By SAS congruency criteria, these triangles became congruent. Side angle side. See, this side AF, then this angle AFE, then this side EF. They are equal to the other triangle, so they are congruent. Then after, by CPCT, we can say that AE equals to CS, right? If A equals CS, then CS is also equals to BE, because see, AE equal BE. Let me write here, AE equals to BE and AE also equals to CS. So why can't we say that BE also equals to CS? Because two things, if they are equal to the same thing, then they are also equal to each other. Euclid's geometry, right? So BE equals to CS. This side will be equal, and they are also parallel by construction, and this side is equals to BC. So ultimately BCSE, this figure became a parallelogram. And whenever we are given a quadrilateral, a polygon of four-sided, then it will become a parallelogram whenever one pair of side became parallel and equal, or two pair of side became parallel and equal. Then it became a parallelogram. So we got that this BCSE is a parallelogram. Next statement we can write that these two will be parallel and EF parallel to BC. See, this is what we have to prove. EF parallel to BC, and we got that. Let me rub this proof, okay? See here. EF parallel to BC. We got now. This is what we have to prove. Next statement we have to prove that EF equal half of BC. And as this is a parallelogram, this is the midpoint of ES, then F is the midpoint of ES, then EF equals half of BC. And at the end, we had proved this midpoint theorem. And as a revision part, at the end, we can say that we can make this proof by taking a triangle, drawing a line through C which is parallel to AB, and making EF produce till it meets that CP, and name this point, and then make these triangles congruent. Then you get this is a parallelogram. Then after, this side will be parallel to this side, and this side will definitely be half of this side. So definitely we get the proof. And I mentioned earlier that I will tell you the converse of this theorem will. Okay, so this converse, if we talk about the converse of this theorem, let me tell you, okay. If we talk about the converse of this theorem, its converse says that if we take a triangle, let us again name it ABC, and we make a midpoint of one side of that triangle E, okay, then if we draw a line which is parallel to the second line from that point, see, it's a line parallel to the second side from this point, then that side or that line will definitely bisect the other front line. Means if we take a triangle, we make a midpoint of one side, and if we draw parallel line from that point to the next line, then that line will definitely cuts the front line into two equal halves. That will definitely the midpoint of the next side. This is the converse of midpoint theorem and the midpoint theorem. I hope you enjoyed the session very well. So keep learning, stay safe, and thank you.